Hello. Hi, good morning, class.
Good morning, sir.
Hi, good morning. So, I think, we'll just start in, I guess, next 2, 3 minutes. I think people are still joining in. Okay, so class, shall we start? I think uh, we have so other people will might join in while we just go with the session. Okay, so class, so like yesterday we were doing we just started off with the linear regression. So let us just start from there, right? So I will request all of you to please upload your data if you have closed your R, and then you can, we will just break the data into test and train. So even before that, if you have any other questions that you would like to ask, please let me know. Right, so I'm just starting over here. So like yesterday what we did was, so we had started with this linear regression. We were trying to understand what exactly it is, where do we use linear regression, and then so we were taking a small data set in order to understand it. So we were working on the data of the salary, right? So this was the data set that we were talking about. And so so this data set has just two columns, years of experience and salary, and where salary is the target variable and experience is something that is the predictor, which will help us in the predicting the salary over here, right? So the thing that we did yesterday was, first of all, we had to bring this data from the Excel into the R. So we have to create a data frame out of this. So let us create that. And once the data is created, so it's a good practice to just check it out if the data is properly loaded up. So you can all take a look at it. Right? So we were able to see that there were 30 rows. We check for the summary. So why do we check the summary? In order to just quickly make sure that if we have any if we have any missing values, or if we have any the I mean, we can take a quick look at what the mean and median is. So this is just a small data set with two variables. So we can see over here a quick summary of that, of the both the variables over here. Okay, so as a part of pre-processing, so I can just write it down, pre-processing. So we can check for box plots in order to figure out to see if there are any outliers in the data. So from this chart, we can see there are no such outliers. And then, we started with the main part where we were trying to understand, like whenever we try to create a model, right? So what we do is the data that we receive. So what we do is we break that data into test and train. So who will tell me what is a training data set and what is a the testing data set?
Well, we divide two parts. We divide in two parts. That is test and train. Test is for testing. That whatever we get the result, whatever but we have, we do test on that. Okay. Training is apart from that. All the things we are doing on training, but from testing, we are just to test for if the data is correct or not. If data, we just analyze all these things in the testing. What I think.
So training is basically the data set on which we create our model, right? So because see, ultimately what we are doing is we are trying to come up with some of the equations from where we can. So we are trying to come up. So in the training data set, what we do is we try to, that data set is something that help us to come up with that mathematical equation, right? So one thing you just all have to be very much clear is, wherever we will be talking about the term model, Okay, so model is nothing, it is just a mathematical equation. So it's a mathematical equation in which what we do is we put the value of the variables and we put our inputs, and based upon that what happen is we are able to come up with the predicted values, right? That is what a model is. So this mathematical equation we are talking about, this is something that is generated from the, so this is generated from with the help of the training data set. Okay, so once I'll just create it, the things will be much more clear to all of you over here. So now what we do is we install this package. So Harmeet, you're right in your understanding. So what is the purpose of set.seed? Right,
So
Raghu?
it will produce the same data, not the manipulated data
No,
again and
many will
again.
not. So it will not change the sample data sets every time. The sample will
Yes,
not be changing.
yes, sir. This is what I am saying. Yes, sir.
So what we do is so all of you upload these CA tools, and then put the CA tools into the library, and then we will do set.seed on this. And then what we did was, so CA tool is a library which gives you a function that is sample.split. Okay, so sample.split is the function that will help us in splitting the data into the testing and training data set, which we will be using in the model building process. So what we do is we create a variable by the name split, and we define that I would like to break my data, right? So we have salary underscore data dollar salary, right? So what we do is when we split the data, we always mention the variable of we mention the name of the target variable. Okay, we say we would like to break the data on basis of this variable into two parts, and we define that ratio. So we want the ratio to be 2:3. See, you can do it, you can define the split ratio either by in the form of a division, like I can say 1/2. So that would mean 50%, right? I can mention 1/3. That would mean 30%. You can also write in the form of percentage. Say, suppose you want to write 80%, you can write 0.8. That will mean 80%. You can write 0.6, that will mean 60%. So both the ways are correct. Either you can write in the form of this division, or you can write in the form of percentage. So we create the split variable. So what does split do? It will give us true false, right? So split will give me the true and false. So I get 30 true and false over here, out of which 20 will be true and 10 will be false. So what is this? This is, what do we call this? These numbers that right now I am getting, in what format am I getting these numbers? So that is the data type, right? So Raghav, so this is basically the data type. Okay, so there are two things. One is data type. Okay, so in the data type, what we do is we talked of, like, we have integer, we have complex, right? We have this character or the string, right? So this is what we have, or the floating points. And then we talked of something about data structures, right? I hope if you remember. So what data structure is it?
Logical.
No, logical is a data type. So logical is also a data type. So you will just mention it, true and false. Vector, right? So this is a vector that we have. So this is vector, and we have, so matrix is Ashutosh, which has rows and columns. right? So matrix is something that has rows and columns, but this is just one sequence. Okay, this is one sequence. Say suppose I want to pick this value. Okay, so if I want to pick this value, so how will I pick this value? I want to see this value, just this value. So how we will see this? Right. So we will say split 5. So we will be writing it. This is the name of my vector, and I would like to see the value which is at 5th position. So if I'll run this, so this gives me true over here. Okay. So now, I think if still some people had any confusions on this, okay, let me just try to uh, say suppose I create a vector over here. Okay. So what I will do is I will create a vector and I will call it as AAR. And say suppose I am putting the values as 5, 7, 10, 1. Okay, now this is a vector that I have created. Okay, now this is a vector that I have created. Now what I want to do is, if you will take a look at this, right? If you will take a look at this vector, these are the values 5, 7, 10, 1, 6, 7, 8, 0. Okay. Now if I ask you that I want to see the values in this vector which are more than 5 or which are more than 8, I want to see only those values. So how will I see that? I just want to see those values which are more than 8, higher than 8, or maybe higher than 7. Let's keep it as higher than 7. I want to keep those, I want to see those values which are higher than 7. Yes, class. I hope the question is clear. I want to see the values which are more than 7. Yes, Raghu, Raghav. Naveen, please share your answers. Right, Hamid. So what you have shared is correct. So Rishabh, you have also shared. Jyoti, Sahil. So guys, this is the first session question that I'm asking you, right? This is something that we did in the first class. How we create a vector, right? Vector, data frames, matrices. So what you will do is say now if you will write this command ARR greater than 7, what is the output will I what output will I get in this case? Okay, Sahil, please tell me. If I write this command, what output will I get? Right, so you will get a logical output in this case. If you write array more than 7, so it gives you the values which are passing your condition, they will come as true, and the values that are not passing your condition, they will come as false, right? So 5 is less than 7, so I get a false over here. 7 is something again less than, so because if I would have said array greater than equal to 7, I would have got true, but this is more than 7, but this is not, so again I get a false. But this is true, this is false, 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 true, and false. Correct? So this is the output that I get, logical output. Now if I say that okay, I want to see those values, the values which are greater than 7, I actually want to see it. See, what this has done is this has something that has given me that first value is false, second value is false, then you have third value as true, fourth value as false. Likewise, we have got the values over here. Now what I want to do is I want to actually achieve that value out. Okay, I'm just interested in seeing those values. So what will happen is if I pass this array, if I pass this array inside this over here, if I assign it to this, it will only throw those values which are true. Okay, it will pass and give me only those values which are true over here. So I have an array over here. So what I can do over here is I will simply pass that I would like to see the values which are more than 7, so which are true in my logical condition. Okay, so now I get only those values 10 and 8. Correct? So what this true and false is doing, this is basically, it's kind of putting a true and false to the index, right? That first index is false, second index is false, third is true, this is false, this is false, false, true, and false, right? So we are just assigning the index over here. So the same thing is what we have done over here as well, right? So we have created a variable split. What this is doing me, this is giving me a vector, right? So this is giving me a vector of what? This is giving me a vector of 30 logical true and false, right? So this split, what will happen is when I'm using this sample dot split, we are getting a vector of 30 true false, where randomly we will have 20 true and 10 false, right? This is what I will be getting. Now based upon that, what we are doing is the same thing that we assigned over here, this array, I am assigning the same thing over here. I would like to create one training data set. In that training data set, what I would like to have is I'm creating a subset. Okay, what is a subset? See, one is, so when I say 1, 2, 3, 4, 5, 7 or 8, I ask you that okay class, give me a subset of 3 numbers. Okay, what you will do is, subset means you will just pick up 3 numbers from here, correct? Someone will pick 2, 3, 4, someone might pick 5, 6, 7, right? So that is what a subset is. So same thing is what we are defining in the code as well. So I am saying I will create one data set by the name of training. in this, I would like to have a subset. Subset of what? I want to have a subset of salary data, because salary data is something which is complete 30 rows. Okay, these are all the 30 rows that I have. So I am saying from this, for the rows, right, for the row numbers where I have split equals to true, I'm just picking those indexes. So in the split, if you see in the split, what is the index of true? One is 1, 2, 3, 4, 5, 6, 7, 8, then 10. So I'm saying just pick those index numbers over here, and that will come in the training data set. That's it. And for test, what I'm doing is I'm picking the index number of false. Okay, is this clear to all? What we have done? Now please make this, just check your training and test data sets. Train and test. You should be able to see them. Okay, so Klaus, please practicing the previous concepts as well. Okay, I mean just that you can if you say 1 by 3 over here, if I just change the split ratio to say suppose 1 by 3. So now 1 by 3 rows will have true and 2/3 will have false. I can change the condition there, because in the over here in the training I want more rows, so I will keep false over here and true over here. The idea is just to have more number of rows in the training data set. Right, so if I change the condition, so 1/3 of the rows will have true and 2/3 will have false. So according to that, I have changed it to false over here. But yes, as a general rule, we should always try to go by the simple technique that we would like to have more trues, and in the training we will keep it as true, and the other one we will keep it as false. Right. So now what we will be doing is, once these data sets are defined, my training and test data sets are created. Now what I will be doing over here is, let me do one thing, let me just copy this in a new file so that I can share this with you. Okay. So now what we will be doing over here is, we will prepare the model. Okay. Now, in order to prepare the model, what we do is I will create a variable by the name model. It can be any name, right? So don't try to, I mean, you don't have to see many times what it happen is that, I mean, learners, what they think is that these are the names that you have to be kind of, you have to use the same names only, right? So that if you will use some other name, you will get an error. It is not that case. These names could be anything, right? You can call it as training data set, right? You can call it as test data set, ABC, XYZ, whatever you want, whatever you are convenient, you can use any name. So these are just the variables that I have defined, right? This split, you can define it as anything. You can call it as splitter, split X, split X, whatever you want, because these are just variables. So similarly, I am creating one variable model in which what I will be doing is I will be storing the results of that model that I will be creating. Okay. So in order to prepare a linear model, what we do is we use a function in the R that is called as lm. Now this is a function. Okay, this R provides us this function, and lm stands for linear model. Okay, so what this will do is this will create a linear model on the data that we will be passing inside this. Okay, now I will come up over here and I will say lm. All of you can just please don't write the code for a moment. Okay, just watch on the screen. Okay, just try to first understand this, then I will give you the time to write the codes and everything. So I'm saying lm, we define the formula. Okay, formula is equals to, so how we define the formula is, we define the formula that I have variable salary, which is my target. So salary variable is dependent on, is proportional to dot. Okay, this is what I write in the formula. Now what does this formula means? I am saying now salary, we have to print the salary based on dot means all the variables. Okay, dot means all the variables. So but right now in this data set, I just have two variables. One is salary, another is experience. Okay, so I am saying I have to print the value of salary based on all the other variables except salary that are there. So technically I am left with one variable, that is experience. Okay, so I will write this down over here. Salary is proportional to these. So this is a tilde sign that I have used. So this is, I'm defining the formula. Okay, now what we do is we tell the data set on which data set this model has to be created. So what is the name of my data set on which the model has to be created? What is the name of the data set, class? No, training data set, right? See, model, what we seen is we create two data sets, test and train. So the model has to be built up on the training data set. So that is train. Okay, so model we build always on the training data set over here. Now, what I will be doing over here is I will run this, and there we go, the model is created, right? So Nandini, so this is what we were discussing over here, right? So we have created test and train data set. So what was the purpose of creating the test and train training data set, Nandini?
To split the data in 2:3 ratio.
Okay, so now after splitting the data, I've got train and test. So why do we, what is the purpose of training data set?
No idea. I mean, it has the two, out of 3, it has 2 data. I mean, out of 30 record, it will be having 20 records. So apart from that, what is the purpose? I don't have idea.
So the training data set is something that we use when you have to create your model, something on which we create our model, and test data set is on which we test our model.
Okay, so why can't we create this on top of salary data?
Okay, see, let me just give you a small example. Okay, so now I think if any one of you have any doubts, all those things will be cleared. Okay, now what I do is say suppose I give all of you, if I give you all of you 10 questions, Okay, I give all of you 10 mathematical questions, and I want to just check that who is good in mathematics. Okay, so I give all of you 10 questions that, okay guys, these are the 10 questions that I'm giving you. Say suppose those 10 questions are of let me say those questions are of profit and loss. Okay, so I want to see who has good understanding, who has understood the concept of profit and loss. So I give all of you 10 questions that, okay, please take these 10 questions and now study them. Okay, you will study all those 10 questions. Now I have to check that whether you have understood that the profit and loss or not. So I will now have to take a test of yours. I will take a test. So in that test, will I give you the same questions or will I give you some other questions? Yeah, Nandini, so I will expect answer from you. So if I have given you 10 questions to practice, okay, I say, okay, Nandini, practice these 10 questions. Now after that, I will take your test to understand that you have understood this concept or not. So in that test, when I will be taking your test, should I give you other questions or should I give you the same question?
Same question. Among the 10, you will be giving some sample questions.
No, so if I give you the same questions, because I have already given you the questions, you would have studied those questions. Don't you think you will be able to give me the right answer?
Okay, yeah.
Correct. If I teach you that, okay, if I say 2 plus 2, I say 2 plus 2, Nandini, you will say this is 4. And you say me, okay, Amit, I have understood how we do the addition. Every time I will ask you to 2 plus 2, you will be able to tell me 4. The moment I ask you 3 plus 3, you will be like, okay, 3 plus 3, you know, is it 8? So that means you have not understood the concept, correct?
Yeah, got
if
it.
I have to test you, right? So if I have to test your skill, I have to give you some new thing. Only if you give the right answer in that case, then I will have that confidence, okay, Nandini has understood it. So that is why what we do is we split the data into training data set. So what my model will do is it will learn from this. It will learn from this. Then I will take his test. Okay, tell me, I will ask the model a question. Tell me the answer on this. If this model is able to give me the answer correctly on this, then I'll have that confidence, okay, my model has learned it. Otherwise, it has not learned. Making sense?
Yeah, got it now.
Yeah. So that is what we are doing over here. So we broke that data salary into two parts. So we are now asking our model to learn from the training data set. So now what I will do is I will write this equation. I will write this formula. So now, so Rishabh, so basically this formula is nothing. So if suppose I have a data set with me, okay, suppose this is a data set with me. Over here, this is some data related to the customers. So now what I would like to do over here is, say suppose I want something that I want to predict the balance. Okay, this is something I want to predict. So this is my predictor variable, this is my target variable, balance is my target variable, and all the remaining variables will be the predictors. So the formula is always like this: balance is dependent on, the balance is dependent on dot. Dot means all. So I have to predict the balance based on all the remaining variables. Okay, so this is what this formula tells me. This is how we write the formula. If I will write balance is dependent on, say suppose I say age. Okay, now in that case, what model will do is it will just use this variable and this variable in order to create the equation. It will not use other variables. If I will say balance is dependent on age plus, say suppose I say region. So in that case, formula will use this column and these two columns. It will not use the rest of the columns. But when you say period, period means model will be using all the variables to understand balance. Okay, so class, to all of you as well, is it clear?
Amit, Raghu here.
Hello, yeah, Raghu.
Amit, I have one question. So, for example, if you have a data set, it will have only one dependent variable. If suppose is there any chances we'll have a multi-dependent variable? Because here we have a balance.
No, it can never happen. We always predict one thing,
Okay.
right? We cannot. So if you have to predict second thing, you will be building another model for that. See, this is like features. Okay, like
Mhm.
everything will be dependent on the other variables.
Okay.
So
So generally we will have only one dependent variable in one data set. Is it so?
yes. No, not generally. It is every time. Every time.
Okay. Okay. Okay.
So like, for example, if I show you something, so if I have this Titanic, this is something that we will again be doing in the class also. Now, this is also an example of the predictive modeling that we will be doing. So if you see over here, these are some variables. Okay, so now this is Titanic. I hope all of you are well aware of this Titanic case study, the Titanic tragedy that happened, the ship that
Yeah.
sank, right?
Mm.
So this is the data that I have of the passengers. So what is the passenger ID, right? We have survived, whether a person died or survived, in which passenger class was he traveling, what was the name of the customer, what was the gender of the customer, age, was he traveling with any sibling and spouse, parents or children, what was the ticket number, fare he gave, cabin, embarked. See, what happens is, like, predictive modeling is nothing. Modeling is all the data that we are collecting, right? On that data, we are just trying to figure out the patterns, that what are the variables that are impacting my dependent variable. Now, like Ashutosh, you asked how to decide which is target. See, we never decide the target based upon looking at the data. I mean, that if we have got the data now, this is something that I will have to predict. Now, the target variable, right? Something that we have to predict, that is something what the value that we have to predict. This is something like a situation that we are going through, right? And we want to be well prepared for that. Okay. Now let me give you the situation. Now the situation will be that this is the Titanic data set. We know that Titanic sank. Now this was a learning. This will be a learning for that. The next ships that will be, traveling ahead after that time, they will have to be very careful that, okay, the tragedy that happened with Titanic, it should not happen with us. So they just would like to be double sure on that. So we had this passengers data with us, that these are the passengers. Now you tell me, what do you think from over here? What would be my objective to predict? Just take a look at this data. So P class is passenger class, name of the customer, gender of the customer, age of the customer, sibling spouse, basically was how many sibling or spouse was he traveling with? Was he traveling with any parents or children? And this is a ticket, the fare, cabin, and from where did he started his journey? Embarked means, like, from where did he start his journey on that Titanic ship? Right, Bhuvneshwari, others? So now, what do you think your objective will be to predict in this date case study? Right. So Ayush, Bhuvneshwari, survivors, definitely right. I would like to see that who was the person who survived and who didn't survive. Okay. Now see, we always have to bring something more like logical context as well to this. Now, if I ask you, don't go by the data, right? Let me just hide this data for you. Okay, now I'm not showing you the data. I'm just asking you this question from a general perspective. I hope all of you would have seen the movie Titanic. I guess all of you would have seen the movie Titanic, right? Do we have anyone who hasn't seen the movie Titanic over here? Okay. So, when the Titanic ship was sinking, okay, when the Titanic was sinking, so the process of evacuation started. Correct? The process of evacuation started at that point in time. So, how was that evacuation taking place? How were they planning that who leaves the ship first and who leaves it afterwards? राइट सो क्वेश्चन इज, जब वो शिप आपका डूब रहा था बेसिकली, तो उन्होंने कैसे डिसाइड किया कि कौन पहले शिप से निकलेगा और बाद में निकलेंगे, कौन बाद में निकलेंगे? व्हाट वाज द प्रोसेस दैट दे फॉलोड? right? So Raghu, Anjal, women and children, right? They would have given a preference ki women and kids, they should leave first. Was there anything else apart from that? Was there anything related to the age, right? That old people should leave first, correct? Old people, women, kids, right? So they will be leaving first, and then it will be male with, young age. They will be leaving in the last, correct? Now, do you think if I have to validate that who survived in that tragedy and who didn't, so will my survival, will it depend on the age? Will it depend on the age? Was age a factor in determining that who will survive and who will not? Yes, it's a factor because on the basis of age, we gave a preference that old should come first and then the young ones. Correct? So now if you will create a model, if you will build a model will be also able to understand this pattern, that he will be able to see where the age was high, the person survived. When the age was low, the person died. Correct? The model will be able to understand this pattern and he will make a
Yeah,
equation
gender
based on
also, right? So we said aged people as well as women and kids. So this
it.
age only will give the what is the person age, but gender also here the factor, right? So whether it's a
Yeah,
woman or man.
correct. So I'm just coming on to that. So we will just
Okay.
go one by one, correct?
Yeah.
So we were talking on the age right now. So now my model will be able to understand that age is a deciding factor. A person died or survived. Now, comes the next variable. Now, do you think the passenger class, okay, there is something called, maybe let's not take passenger class. I also have the name in the data. Do you think name will impact that whether a person dies or survives? No, right? Because now we also know from a general perspective, no one said on the Titanic that, okay, all the Johnsons come first, then Williams will come. No one said that, right? So again, I know that name is not a deciding factor whether a person will die or survive. So if you will use the name in your model, it will not take it as significant. It will tell you that this variable is not significant at all in terms of predicting that whether a person will die or survive. The model will also tell you. See, now we are taking both the things together, right? Our own general sense and what the model will tell us. Okay, and I will show you this thing once we will make this model. This is the topic of logical regression, but right now, since I just want all of you to understand like how the model building is done, so you should be able to understand it. That is the reason I'm just explaining you this part. Now, let's take the gender. Was gender a important role in terms of telling whether a person will die or survive? Right? So it is a factor. So because we know that the females were given preferences. Now, if you see, I am able to identify by my general sense that this variable and this variable are playing significant roles. Okay. Now these two variables also have some interaction. If you see, if there is a female of young age and there is a female of old age, who will be given a preference of these two? Old, a female of old women, right? So now my general sense is also telling me this, and all these things will be identified by the model as well, right? That is where the mathematical equations comes in, and they read the data into the backend, and there are a lot of multiple equations are created into which the data is then put, and it is checked whether it is giving the correct result or not, and then the final equation is created. Okay, so this is how the model building happens. So similarly, you will pick up the other variables, right? Like for example, passenger ID is something which will not be important. This is just a identifier. Similarly, passenger class, right? Do you think passenger class would be important? 1, 2, and 3. If a class 1, class 2, class 3. No, so all of you are saying no, but technically what I feel is yes, right? Because definitely what happen is that the higher passenger classes, they have better safety facilities. If you all will know, right? They have better evacuation, the setup that these class have, right? If you travel in a plane, when you travel in a plane, you might would have seen that the people who are sitting the near the emergency exits, don't you think they have a higher chances of exiting or leaving the airplane if something happens over there, right? Don't you think that the person who are very near to that emergency exit, they have a higher chance that they can right away, if some tragedy happens, they can jump out of the plane by opening that door, right? So that will also play a role, that who is sitting near to that tragedy, because see, you cannot control that crowd. The people will actually rush to save their lives. So somehow, somewhere, who the people who will be near to that exits, they will try to safeguard themselves as early as possible. Like, it's like a general notion. So these are the things, these are the things, but basically we just all understand what will be happening over there. It is just that these modeling impacts, they generate a mathematical stuff for that, so that later on we do not have to think upon, because I cannot do this stuff manually, that okay, his age is this, gender is this, he will survive or he will not survive, right? So I can't do that stuff over here. If you see, technically, if you see 0 and 1, 0 means died and 1 means survived. If you see male of 22 years, I can see from the data he's died. He's young male, right? Everywhere you will see young males, they are mostly dying over here. See the pattern, these are the patterns that these models try to identify. Everywhere a young male you will find, mostly they are dying, right? If you see over here, getting it? But there are still some young males who survived also, correct? You can see over here, this is a young male who has survived, but there could be some factor which would have been related to it. It could be that the class he was traveling in, maybe that impacted that he survived, correct? So that is how all these variables are read by the model, and they give us the answer over there. So let us jump back to this. Now what I'll be doing over here is, I am just building that model for me. Now we are just building that model over here. Model equals to lm, formula, data equals to tree. There we go. So model is ready. So model has been created. Now what I will do is, I will check out the summary. I would like to see what is the summary of my model. So this is the overall information that my summary of that model is. It will not be exactly like a mathematical equation, but somehow it is a mathematical equation only. Okay, so this data was on salary and experience. What will be a person's salary based on the experience? Okay, so when you create a model, so there is a lot of stuff that comes up, but we are not interested in all the information. We will just be taking a look at the information that is important for us. Okay, so this is intercept. What is intercept? What was intercept? Can anyone tell me? So
The equation line cut the y-axis.
Yeah, so the equation that we studied, y equals to mx plus c. This c is also called as, the c is also called as intercept. C is also called intercept. Okay, because if you remember, when we create this x and y axis, see, if I am saying that my line is passing from here, in that case, this is, suppose this is 0. So when x is 0, y is also 0. So that means c will be 0. Okay, when my line is like this and my line is passing from here, okay, now over here x is 0, but at x equal to 0, is my y 0? Is at x equal to 0, is my y 0? No, right? Y is not 0. So this is, there is some constant value. when the value of x is 0, still y has some value. That is what we understood, y equal to mx plus c. If a person has 0 experience, will I say he will have 0 salary? No. If he has a 0 experience, he will still have some salary. That is what is called as intercept. So that is the intercept, the value of c that you have got over here, 24,813. So if a person will have 0 experience, you call it as an intercept or you call it as a constant. This is what his salary would be. This is the value of m, the coefficient m, 9418. So now my equation has come up like this. If I write my equation, my salary is, my model is salary equal to 9418 multiplied by experience plus intercept. So intercept value was 24813. 24813. Now this is the final equation that I have got. So suppose if a person has 3 years of experience, so what will be his salary? So his salary would be 9418 multiplied by 3 plus 24813. Let me check what it gives. So this is giving me, if a person has a experience of 3 years, he would be having a salary of 53,000. Let me go and check my data. See, there is a person who has salary of 3 years. His salary is 56,000. Similarly, there are also people, if you see over here, in the range of 3. Some are having 54,000 also, 64,000 also, 57,000 also, right? So there are variety of numbers that are present for 3 years of experience. And my model is giving approximately around 53,000. So can I say that I can trust my model? Right? It is somewhat nearby that range only what we are getting over here. 60,000, 54,000, 64,000, 57,000. So see, approximations can never be 100% correct. There will be a marginal error of 10 around 8 to 10%, 10 to 12% as well. The error will always be there. So based upon this, if I see, this is what the number I am getting. Let us check it for the 4 years. What my model is giving as the output. I just have to change it into 4. If a person has 4 years of experience, my model is telling that he should have a salary of 62,485. Okay, so if I see within the range of 4 years, we have some salaries over here. Okay, so now this is what I'm getting in this. My model is predicting somewhere around 56,000 or what was it? That was 62,000. So my model is predicting 62,000. So 55,000, 56,000, 57,000, 61, 67. So within that range, it is giving me around 63,000 as a salary over here. So Sahil, 9418 is the M, the coefficient. This equation's M is, value of M is 9418. X is the experience that I'm putting up over here. Okay, class? Any questions over here? Okay. So now, I would like to define something over here. So I just wanted to give you a flavor that how this linear modeling happens. Now, what will be the hypothesis testing in this case? If I say I am creating a linear model, what shall be my hypothesis test? So for this salary and experience model that I'm creating, what is the hypothesis test that I will create? What will be my null hypothesis and what will be my alternate hypothesis? So Bhuvneshwari, this will be a null hypothesis or will this be an alternate hypothesis? Once the thing that you have mentioned. This will be an alternate hypothesis, not the null hypothesis. So null hypothesis is a general belief that we are following, right? So we are, remember, so null hypothesis is something that we have already assumed true. If I'm already assuming this as true, that the salary will be dependent on the experience, there is no need to create a model, right? What are we trying to achieve? Remember the statements, that if you remember the statements over there, what we try to achieve is alternate hypothesis. Our goal is always to achieve alternate hypothesis, correct? So the model building that you do, if I am creating this, if I show you the Titanic data set again, okay? If I show you the Titanic data set again, where is it? Yeah. Now, if I ask you, okay, that what are we trying to find out this in this model? If you will create this model, what will be your objective? Why? What are you trying to figure out? When you will build a model to figure out, because see, if you already know that who will survive and who will not depends on what things, will you create a model, right? If suppose, let me give you another example. You have to launch a new car in the market. You own a car company. And if you already know that if I have to keep the pricing of the car, these are the variables that I need to take care of, will you create a model? Tell me, will you create a model? अगर आपको पहले से ही पता है कि यार की गाड़ी का प्राइस तो भाई इसके इंजन पे डिपेंड करता है और इसके माइलेज पे डिपेंड करता है, तो आप मॉडल बनाओगे अपना. विल यू स्पेंड दैट टाइम ऑफ कलेक्टिंग द डेटा, then analyzing the data, making a team of data scientists sitting in your company who will say, okay sir, ये तो आपको पता ही था, ये प्राइस होना चाहिए इसका. Will you invest that money? No, right? You are actually building the model because you don't know that what are the factors which impact the price of the cars. You do not know what are the basically variables that impact that a person will die or survive, right? That is the reason you are building a model. You want to identify कि कौन सी ऐसी चीजें हैं जिससे impact पड़ेगा कि बंदा बचेगा या नहीं बचेगा, right? So when you do these tests or when you do these models, when you create these models, like if you would have seen, have you all, I'm not sure that if you all follow this thing of the COVID-19 vaccine, right? This COVID-19 vaccine, how many of you read the news of these COVID-19 vaccines on a regular basis? See, everywhere, you know, this COVID-19 is actually something that has actually given a lot of thrust to this, you know, the data analytics. There is a lot of data analytics that is being used in the COVID-19 situation. Have you heard the term over there, false negative? What is false negative? Or if you would have seen, if you would have recently seen, if you would have read that news of this, you know, Pfizer has launched this, the medicine, which is, they are saying is 95% effective. Have you read that news? Did anyone read that news? If you would have read that, you know, the article over there, it was explicitly mentioned that the scientists, they target for 95% efficiency. That is the base that they take before they can launch the medicine into the market. I'm not sure if you read that article, but it was written in one of these articles I was reading. It was explicitly mentioned. So they are still taking that 5% chances of error. Okay. So error hota hai, that is the chances that your result will be false. That might be, you are saying that the person will not be infected by that medicine, but he can get infected, right? That is exactly what that 95% means, that there are 5% chances that even after taking the vaccine, you still get infected with that. Okay, that is again data modeling only. That is the predictive modeling and the results that we talked of. Remember when we were talking of the hypothesis testing, what was the benchmark that we talked of? What was the benchmark that we take for the significance level? The p-value that we were talking of, the values that we identify, which we take as a general standard. If you remember, that was 5%. Right? 2.5 on this, 2.5 on this. This is a general notion that we talk and walk with. Remember the 5% value that we talked of? Miss class? Okay. So why I am telling you all these things? So there is a story. Okay. Now you should all be able to relate to it. So what is my hypothesis test? So let me write that down. Hypothesis. I am saying my null hypothesis is, my salary is not dependent on, my salary is not dependent on experience, and my alternate hypothesis is salary is dependent on experience. This is something that I have to prove. So what we do is, whenever we are working the null hypothesis, alternate hypothesis is something that we are looking out to prove, right? This is something that will bring a change. Our goal is to always come up with the alternate hypothesis. Remember that judge case. So when a judge sits, he sits with an assumption that he is innocent, right? But our goal is to prove that he is criminal, right? That is why we do that much of effort of collecting the evidence, filing a case, and doing all that stuff. So same way over here in the models, our null hypothesis will always be that my target variable is not dependent on these variables, and my alternate hypothesis is that yes, it is dependent on that, and we try to find out the variables which impact that. So now if I'll come back to my model over here, so in this model, if you will see over here you have that p-value. In this model, the model is giving you the p-values. Here are the p-values that we have. So we do not have to go to tables and all. So this is the p-value. Is this p-value less than 0.005 or less than 0.05? 5% is 0.05. Are these two values less than 0.05? Right? If you remember the curve. So we have the 5% that you have as the index. We used to keep it like this. This area used to be the null hypothesis. This area used to be our alternate hypothesis. Correct? This used to be our alternate hypothesis. If we are talking about the two-tailed test. Am I right, class? So now, are these two variables, these two p-values, are they less than 0.05? Please take a look at it. So this is 3.7 e raised to the power minus 0.8. And this is 3.43 e raised to the power minus 13. Is it less than 0.05 or is it more than 0.05? Right, Ashu? So all of Baldev, Raghu, so this value is less than 0.05. That means this value is lying in this area. Less than 0.05 means it is lying in this area. Correct? If the value is less than 0.05, what does that mean? Is my null hypothesis true or my alternate hypothesis true? Alternate, correct? So that means your alternate hypothesis is true. So that means my model is telling me that my year of experience is something that is impacting my this salary. So this is what that model is telling me, these 3 stars that you see. So 3-star means that the value is approximately 0. If the value is around 0.01, that in that case you will, this is just like a reference. If you are getting 2 stars, that means the value is nearby 0.01. Then if the value is 1 star, then it is 0.01, then 0.05. And if you don't see any star, that means you have actually passed and your values have increased more than 0.05. And this is something that we take as a standard also. So in all the languages, whether you will work in R or in the Python, 5% is something that we take as an industry standard. And based on that, we pick our variables. So all the variables that will be having the value less than 0.05, we will be able to tell that, okay, yes, these are the variables that impact my salary.
Amit, Raghu here.
Yeah.
One general question. Okay, so what I understood, I think most of us understood, even Ashutosh asked, what we consider equal to, greater than, or less than, we need to consider as a null hypothesis. For example, if we say positive statement, okay, salary is greater than this month, salary equal to, but here we said salary is not dependent on this one. So that we need, here we are considering as a null hypothesis.
Yes.
So you understood my question, right? So what we thought equal to, not equal to means it's an alternate.
No, that was not never the alternate over there, right? So if you remember over there, so what we did was we did some equations that we are saying at least or least, right? So what we are doing over here is we are saying not equal to, which is again equal to only, right? Somewhere like to, which is with a not sign over here, right? So you have to understand it from the perspective that the proportionality. So this is something not dependent on. So see, I've just given you the complete understanding over here, like what null hypothesis and alternate is. So alternate is something that we are trying to prove, right? That is what we have in the alternate. If you just remember. So
Yeah, Amit, but what we consider positive, that is equal to, if its salary is depend on this, then it is a null hypothesis. Not means alternate. That's what we understood from that symbols as well as statement. So is it not so, right then?
So there were two things, right? We would have studied. So we also studied one portion that alternate hypothesis is something that we are trying to prove, correct?
Yeah.
Right? So that is a challenge that will bring a change. And null is something that is already happening and that is already going around, and we are well aware of that thing. So when we say that Maggie should have the concentration less than 2.5%, so my null is that it is already having that. But my challenge was to prove that okay, it is not, it is having more than that 2.5% of that lead inside that. So see, the same scenario you will have to pick up from there. So if you say equal to and not equal to, so if you see, we are not saying that salary is equal to. See, please do not get confused by this term. I'm not saying that salary is equal to experience. I am proving over here that salary is dependent on experience. I'm not saying salary equal to this. So I'm just creating a scenario of alternate and null hypothesis where I'm saying in my null hypothesis that it is not dependent. And over here, I'm saying salary is dependent. So nowhere I'm using equal to or not equal to over here.
Okay. So the statement of what I feel is not dependent is a negative. So it's not equal, not, so that not means it will come under alternate. That's what a little bit confused.
Okay.
Salary is not dependent, so it's not dependent, so it will come in alternate. So the statement is the alternate hypothesis. That's what I understood. So salary is dependent on experience is similar to equal to it is a null hypothesis. So by statement I had confused.
No. So the statement will be the null hypothesis would be the salary is not dependent, and the alternate will be salary is dependent.
Okay. Okay.
Okay. So the star symbol is just for the representation that if the value is very small, that means it's a good thing. So it is giving 3 stars. If the value is little more, if suppose value was equivalent to 0, you get 3 stars. If the value is increasing 0.01, that means significance is decreasing. R will show you 2 stars. And further, if it goes further down, it shows 1 star. Then for 0.05, it will show you a period. And if it will be 0.1, it will show you a space. This is just a legend of that. So this value is almost approximately equal to 0 itself. So that is why you are getting 3 stars.
Samir, does it mean from 3 star to 0.1 is something we can say it's passed to fail stage?
Yeah, so you're moving towards that. See, for example, if suppose there is one variable. Okay, so let me show you. So if I am saying there is one variable for which I got the value of 0.01. Okay, and another variable I got value as 0.02. Okay, so if you see both are less than 0.05, both are right now less than 0.05 over here. If I see, so what we are saying is, but this value is much much smaller, right? If I create the same curve over here, okay, if I create the same curve over here, okay, so 0.02 will be here, 0.01 will be over here, right? So that means out of these two variables, this variable is more significant and this is little less significant than this, although both are significant, but out of these two, this has higher power and this will have lesser power in terms of predicting something. Okay, so this is just like, you say that if you give a movie a 5 star, so you will, by looking at that 5 star, you understand that this movie is really great. But if the movie has 4 star, you say, okay, the movie is good, but not as good as the movie that had 5 stars with it. So this is the same stars that are being represented over here. Okay, any other questions, class, on this?
Yes, Amit, I cannot be able to run that code. Its model is equal to lm formula, so salary tilde dot data is equal to int. I cannot be able to access code.
Can
Yeah.
you share your code on the chat, please? So all of you, now you can write your code, please. So in the meantime, now you can write your code.
Well, I'm on the call actually on the phone.
So you are okay. So what is the error that you are getting? If you can just share, please make sure the salary S
Error
should be.
in error.
Please ensure that S is in the capital, right?
Yes, right. Just a minute. Just a minute. Yeah. That's a
Got it?
mistake actually. That's a mistake.
Yeah.
Thank you. Yeah, I got it. Thank you.
So Sahil, what is standard error? So what was standard error? No. So there were two things that we studied. One was standard deviation and one was standard error. So what you are talking about is that is the standard deviation over here. Yes, Raghu, sigma divided by root n. That was standard error. Something that we studied in the central limit theorem.
Amit, Raviya. Okay, so just again regarding the hypothesis testing. Okay, for example, if company have the statement, okay, this resource is not eligible for a promotion. So can we consider this as a null statement, null hypothesis? And we want to alternate as, yes, this resource is eligible for promotion.
So that will be the case, right? See, because if the resource is eligible for promotion, you would have already given him it, right? Because you want to prove it that he is not eligible. That is why your null hypothesis is that he is not eligible, but the resource has to prove that yes, he is eligible.
So that will be alternate, correct?
Correct.
Okay, so it's based on the state. So we cannot consider by not or equal. It's based on the statement.
So that equal to less than equal to was based on that example that we were talking at that time, right? So like the examples that I gave you, that a company has a revenue more than this or greater than or equal to than this. It was based on that, the context, that how we are defining the null and the alternate hypothesis.
Okay.
Right. So if we were talking on that numerical terms, that this has more than, less than, equal to the, if you remember, we had all these equations equal to like this only, that the the lead is less than equal to 2.5. The Flipkart has revenue more than 14 billion, less than 14 billion. So those were the kind of questions that we were studying at that time. But if you just try to, if you just see in a overall notion, so it is more like something that we are trying to prove, that is our alternate, and something that we already know is null hypothesis.
Okay, so if someone says the statement, then we consider that statement as a null, and we want to against it, then we consider as an alternate. Correct?
Alternate hypothesis. Correct.
Got it.
Yes. Have you all written this? Shall I move ahead? So now, because I would like to introduce you with a little more concepts over here. And now we will try to understand these regression in a lot more. See, basically, whenever we will be creating this linear model, we just take a look at these things. One is this, and another is this, R square. So these are the two things that we are always interested in. So let me just explain you now. Let us deep dive into the linear regression in a better way. Okay. Right. So Sahil, if you remember the central limit theorem, right? Standard error, right? So this was what we discussed, sigma divided by root n. Okay. See, now let me give you a small, let us understand by this over here. Say suppose I have a small data set over here, okay? Now, this data set is basically on a particular day. So this is the data of a, suppose a small bar. So this was the temperature and this was the earning. Okay, this is the data of the bar over here. So the bar, or you can say ice cream parlor, maybe you can call it as. So because the word is used bar takings over here, so we'll call it as a bar. Okay. So by looking at this data, what can you tell me? Just take a look at this. All of you, you have to give me some of your inferences on this data. Small, quick data.
Raghu here. So when the temperature is more, the sales is good. So if the temperature is winter season, the sales is less. Is it correct?
Okay, so we have so temperature, Rishabh, Raghav, and you were also saying the same thing, Raghu, right? So if the temperature is changing, so there is a change in the bar takings that we have. So if the temperature is increasing, the sales are increasing, and the temperature is going down, my sales are going down, correct? And you can see this from a diagram as well. Over here, a quick diagram that we have. So we have just plotted over here. Right now, don't pay attention to the line, please. Okay, just see over here. So when the temperature was this was the sales, right? So I can see that thing from here. When this is the temperature, this is the sales. So what we have done is we have just plotted that thing onto this line over on this the chart over here. Now what we do is, what is linear regression, right? So in the linear regression, what we do is we try to create the best fit line. Okay, we try to create a best fit line whenever you are working on your linear regressions and everything. Now, what is the best fit line? Does anyone know what is the definition of a best fit line? So the equations that we have been talking about since yesterday, that every time we are saying that we have a line like this and y equals to mx plus c, y equals to mx plus c, what exactly that line is, right? Y equals to mx plus c, right? So now I have shown you something. Now I am showing you in a reverse engineering way. Like, how do you get this line y equals to mx plus c? Right? So Raghav, so you said, right? So basically the line that passes the best from these points. Okay, see, definitely over here, there could be multiple lines that can be created. I can have a line like this also, right? I can have a line like this also. So now how should I decide that whether I should take this line or this line or this line. Okay, so this is something that is decided on the basis of there are multiple lines that will be created. The line that has the minimum or the least, the line that will have the least distance from all the points, right? That line is considered as the best line. Okay, the line that has the least distance from all the points, that is called as least distance, or that is called as the best fit line. Are you all getting it, this class? Baldev, Ashwini, Nitin, Swati. So now what we do over here is we try to figure out, or we try to create a line that best fits. So the line that is having the minimum distance from all the points. Okay. Now, how will you find that distance? How will I find the distance that, okay, this line is giving me the minimum distance? Is there a way of doing that? See, all the things, it will just come back from your class 9, 10th only. Nothing outside that. How can I find the distance of this point and this point, this point and this point, same way this point to this point? How can I find the distance? So Naveen, what is the error over here?
So distance from the predicted and the actual.
But predicted line I don't have even right now, right? I have not even created the predicted line as of now. I don't know what is that predicted line is.
The equation which we have.
No, we do not have right now this, right? So my question is, we do not have that predicted line right now. We are trying to find that best line. I am trying to find that best line, the line that will be used as a predicted line. So that line I am trying to find right now. So what happen is, I will find, I have multiple lines. So how will I find that which is the best line? Because the best line will become my predicted line. So for every line, I will be finding the distance. My question is that how we get that? We decide the line which has the minimum distance. So how do we find that distance? So if you will see over here, so what we do is by the coordinates, right, Sahil, as you mentioned. So what we do is, so what we do over here is we will try to find the distances, difference of distance between these. We will, this is a x and y coordinate. Okay, this is x and y coordinate, x1 and y1. Okay, similarly, you have okay. So what we have over here is we have x and y over here. So what we do is we find that the subtraction by x2 minus x1 plus y2 minus y1. That is how we find the difference, if you all remember. Right? x2 minus x1 plus y2 minus y1. So we subtract them and we add them. That is what is called as the distance between these 2 points. Okay? Are you getting it, class? x2 minus x1 plus y2 minus y1. So suppose if I give you some pointers like this, if I give you a pointer like this, I have one coordinate as the basically say suppose one coordinate is 3, 2 and another is 4, 3. Okay, How will you find the distance between these two? You will say x2 minus x1, 4 minus 3 plus 3 minus 2. Correct? So 1 plus 1, that is 2. So I get the distance as 2 over here. Getting it, guys? This is how we find the difference between the two coordinates. X2 minus x1 plus y2 minus y1. Right? So same way, we find the difference over here. Okay. I will find the difference of this point. I will same way, because see, this is a coordinate. See, now you have to take into that this is a graph that we have created, right? This has some coordinate, temperature and a sail, and same way this point also has a coordinate, temperature and a sail. Correct? So I have both the coordinates over here. So what we do is we find the temperature, the difference between those points. I will find this, I will find this, I will find this, and what I will be doing is I will add up all these numbers. Okay, I will be adding up all these numbers. So wherever the sum comes to be the lowest, that becomes the best fit line. Okay. Please, class, please let me know if you all are with me, because there is a catch that I will be right now talking over here. Okay, so Bhuvnesh, basically it is, see, I draw a line. Okay, so I draw a line over here. What are the x and y coordinates of this point? Can you tell me what are the x and y coordinates of this point?
X is somewhere closer to 15, so 14, I guess, and Y is closer to 1500, so a little more than 1500.
Okay, so let us take it as 50, like 1600. Let us take it as 60. This right, this overhead stuff. So you have mentioned that x is around 14 degree, correct? And y is, let us take it as 1800. Okay, because this is somewhere, this range will be like between 1500 to 2500. So 17 or 1800. So I'm roughly taking it as 1800. Correct? So you're right in this case. Now, what exactly parallel to this, there is this line crossing. What are the coordinate of this line? What are the coordinate of this particular point, which are exactly parallel to this point? What are the coordinates of this?
14 again, X, and this I believe is either 1300 or 1200.
Correct. Okay, so I'll take it as 1300 in this case. So I will say the x remains the same. So x will be the same only. So 14, I will call it as, say, suppose 1300. Okay, so this is something that I can see because there is a difference between. Now what I will do is I will find the difference of these 2 points. How will I find the difference? X2 minus x1. So 14 minus 14, that becomes 0. Correct? 14 minus 14. So I will say 14 minus 14 plus y2 minus y1. Y2 is 1300 and another is 1800.
500, yeah,
So
500.
500. So I get 500 over here. So total I will get a difference of
0.
500.
Yeah.
Okay. So now similarly, this is the distance that is of 1 point. In the same fashion, I will find the difference of all the points. Can I do the same thing for all the points now?
Yes.
I can do it. Okay. So for example, for one of the points, I get the distance difference as 500. Another point, I get a difference of 300. Another point, I get a difference of minus 500. Another point, I get a difference of minus 200. Then I get a minus 100. I will get such differences for all the points. Correct?
Right.
Now what I will do is I will add all of them. I will get one single number.
Correct.
Now, is it now, this is something that I've explained. Is it all clear to everyone? What I've done? No, so we do not ignore the sign. So positive and negative will be there. So yeah, definitely this is Y2. This should have been minus 500. So 1300 minus 1800, that should be minus 500, right? So you can call it as this minus 500. This will become plus 500. So according to that, we do not ignore the symbols over there. Perfect. Now this will give me one single number over here. Say suppose that comes out to be 100. That comes out when I summarize all these things. I get that as 100 over here. Correct?
Right. Right.
Okay. Now what I will do is, similarly, I can say that no, I can have a line like this also. I will say there can be a line like this also that can pass in. Okay.
Taking different other
Line.
lines, as in similar, as in the training data will have a different points in that case, right?
No, right. Please, forget about the training and testing.
Okay.
Just forget it. Okay.
Okay.
So now this is just mathematics that we are talking of. So now what I'm doing is, so like Bhuvneshwari, you said that this is the best fit line that is crossing through all the points. But I say that no, this is the best fit line that is passing through all the points. Okay. Now, how will we prove that, whether this is the best fit line or this is the best fit line? So the criteria for that is we find the distance like we did over here.
Right.
Okay. So now in the same fashion, you will tell me, okay, Amit, calculate your distance now. I will follow the same approach. I will say, okay, this point to this point, what is the difference? Plus this point to this point, plus this point to this point. I will find all the distances again. Same way I will get the numbers that will come like this. Say suppose one was minus 300 plus 700 minus 250. And now when I add up all those numbers, I got a difference of, say suppose 200. In your case, the distance was coming as 100, and in my case, it came out to be 200 when I added up all the numbers. So our goal is the line that has the minimum distance, right? The line that has minimum distance is considered as the best fit line. So now your line has a distance of 100, but my line had a distance of 200. So your line will be considered as the best fit line.
Got it. Got it. One other question. So is this the reason why, one of the reasons why we don't consider outliers? Because then the line will be off, right?
No, see, outlier is something that will actually impact the results. So outlier is something that we check on each variable, right? On each variable, we check that, okay, if I pick up the variable column of salary, so I want to ensure that if I'll find some average salaries or something like that, they will actually impact my result. If my salary is very high, right? So my average will change. Average of the line will change in that case.
Right, but even in this case, so going back to, as in, and this is a model we are building on the training data, right? So again, just for example, so in case we are considering the outlier, would that not affect the model?
Yeah, it will affect the model, right? So it will affect the model. That is why we remove them or we resolve them. So it impacts the
Correct.
model.
Right. Thank you.
Okay. So now over here, so anyone, any questions up till here, please let me know. All clear? Okay. See, now what happened is, now there is a small catch. See, I'm just testing all your mathematical skills over here because I just want all of you to be clear on this. That is why I'm just doing these things in a little of breakups over here. Okay. I have a 1 point over here and I have 1 point over here. Just consider these 2 points. Just consider these 2 points for now. I find the distance of this point. I find the distance of this point. Okay. I find the distance of this point and this point. What will be the difference of these 2 points? Or what will be the total of these 2 points? The total distance of these 2 points? Which class? See, I'm not asking for the exact numbers, right? I'm not asking for the exact numbers, just approximations. I do not want the exact numbers over here. Approximations. This point and this point. If I find the distance of this point, I find the distance of this point, and then I add up. What approximate number will I get? So Subhakran says 1000. See, if you will ask me, I will say 0. Okay. If you will ask me, I will say the approximation that I will get over here will be 0. See, this point is somewhat at a similar distance on the top side, and this point is somewhat on a similar distance on a lower side. Correct? Am I right in saying that? ये आपका ऊपर की तरफ है पॉजिटिव डायरेक्शन में और ये नीचे की तरफ है, तो यानी एक जगह पे आपका डिस्टेंस पॉजिटिव आएगा तो एक जगह पे आपका डिस्टेंस नेगेटिव आएगा, राइट? क्योंकि एक लाइन के ऊपर और एक लाइन के नीचे है, तो यानी एक डिस्टेंस आपका पॉजिटिव हो गया और एक आपका डिस्टेंस नेगेटिव हो गया, राइट? सो पॉजिटिव एंड नेगेटिव गिव्स यू 0, right? Positive and negative gives you 0. So now, there is a high chance, there are high chances that suppose my points were such that, 1 point is here, 1 point is here, 1 point is here, 1 point is here. Actually, as per the mathematics, there can be lot of ways I can create the lines which will give me the distance as 0. There will be lot of permutations and combinations on the basis of which I will be able to create a line so that my total comes as 0. My total distance comes out as 0. I can create multiple such lines, right? I can create multiple such lines by which I will be able to find the total distance as 0.
Amit, question like, this is a data set with a very small amount of data in it right now. Imagine if we have 4 times more than of this data, then how do we measure? Because then there would be a lot of points, right? So is it a function within the system which does it for us, or something we have to take care of it?
No, so the system will do all these things for you. We just have to understand the concept. I'm just trying to make you understand the concepts over here so that you understand the mathematics behind the scenes. Okay, see, if I'll just explain you that this is how you create the linear model, this is p-value, and now you do it. So you will be able to create the models, but you will not be able to understand the exact picture behind the scenes, right? So that is why I'm just putting all these efforts so that you can understand all the mathematics over here. Okay, so now if you see, I'm just trying to explain you the mathematics only. So lines by which I can have the distance to be coming out as 0. Correct? मैं बहुत सारी लाइंस यहाँ पे बना सकता हूँ कि जिससे मेरा टोटल डिस्टेंस 0 आ जाएगा. सो अब टोटल डिस्टेंस अगर मेरा 0 हो गया और मेरे पास मल्टीपल लाइंस हैं, सो हाउ विल आई डिसाइड द बेस्ट लाइन इन दैट केस? अगेन आई विल बी इन दैट सेम लूप सिचुएशन. वी विल बी लाइक, यार हमने लाइन तो बना ली पर अब तो मेरे पास मल्टीपल लाइंस आ रही हैं जिसपे मेरा डिस्टेंस 0 आ रहा है. नाउ हाउ शुड आई डिसाइड? अब 0 से कम कहीं डिस्टेंस आ नहीं रहा है और मल्टीपल लाइंस ऐसी आ रही हैं जहां पे मेरे पास जो डिस्टेंस है it is coming as 0. So how will I come up with the best line, right? So now here comes the thing to know. How can you make a negative number positive? How can you make a negative number positive? आप एक नेगेटिव नंबर को पॉजिटिव कैसे कर सकते हो? Square, right, Raghu? If I take square of a number, it will always be positive. 4 का square 16, minus 4 का square भी 16, right? 3 का square 9, minus 3 square also 9. So positive, whether you give a negative number or you give a positive number, the square is something that is always positive, right? So that is why, so that we do not land up in such a situation that we have to find that we get zeros and zeros, lot of zeros. What we do is we actually do not take the difference, we take the square of the difference. So in that case, what will happen is your minus 500 and 500, they will not cancel out. So 500 and 500 will be 2500. This will be again 2500. If you will add up, you will get 5000. So on basis of that, you will find the minimum distance of the line. So जहां पे आपका square करने के बाद minimum distance आ रहा होगा, that will be considered as your best fit line. Okay. Okay, so Laz, I think we can take a short break over here. You can all have a breather and we can continue after that. Yeah, hi, Tash. Shall we start now?
Hi, Amit. Can you please give me a brief about that all thing because it's a network issue here, so that's why I'm not able to understand that. I just understand that it's a positive correlation relation between in this chart. Okay, can you please tell me about the mathematical calculation?
Sure, I'll just do that. Okay. See, so what we are discussing over here is that what we do is we try to create the best fit line over here. Okay. So you have some points. What we have done is we have just put it all the points on this chart, all the points that we have. So we have plotted these lines over here. So that equation that we studied, the y equals to mx plus c. Okay. The y equals to mx plus c. That equation is basically the best fit line, right? This is what we have been discussing up till now. That y equals to mx plus c is the best line, the best fit line that you have based on the data. So how do we get this line? Is this line is calculated by, we can have n number of lines over here. I can have a line like this. I can have a line like this. Correct?
Right.
Now how do I consider which line is the best? Whether I should go ahead with this line or this line or this line that I already have on this chart. Okay, so for that, what we do is we calculate the distance of these points from here to here, from here to here, right? For all the lines, we will calculate these distance. So for whatever line, we get the distance as the minimum, right? The distance that is minimum, right? For example, if you have to go to watch a movie, right? What you will do is you will always find, when you say what is the best distance to go to that cinema hall, what are you asking for? You are asking for that distance. The best way is the distance that will take the minimum time for you to reach over there, correct? Now the same is the concept over here. I'm trying to find the best line. The best line would be the one which has the minimum distance from all the points. Okay, so for that, what we do is we actually calculate the squares of the distance. Why we calculate the square of the distance? Because see, one distance is over here. This is a positive distance and this is a negative distance. So there can be an instance that where positive and negative, they will cancel out and you will actually get a distance as 0. And there can be many lines which can give you the distance to be as 0. If you have multiple lines which are giving you the distance as 0, you will not be able to decide which is the best fit line. So that is why we take the square, because when you square the numbers become positive and you can never have the sum as 0 in that case. So when we will add them up, you will get a number. So you are trying to find that line which gives you the minimum number over there. So that is called as a best fit line. Okay. Yeah. So others, is it all clear to all of you? Anyone, any questions on this?
The coordinates value 1800, 1300, how it's come actually? Can you please?
Sorry?
The coordinates value there in the notepad.
Uh-huh.
How it comes?
You are talking about these coordinates?
Yeah. Yes.
See, these are basically so if I ask you this point, what are the coordinate of this point? Yes, Arvind, what are the coordinates of this point? What is x and y for this? See, x's you find from here. This is the x-axis. This is the y-axis. Okay. So where is it meeting on x? It is meeting somewhere around 13 or 14.
Yeah, 13, 14.
Right. And on the y, it is meeting somewhere around 16, 1700.
Yes.
So that is what x and y is written over here. 14 and 1800. And similarly, you find the coordinate of the point that is lying over here. Okay.
Now we got it. I got it.
Yeah. So now class, let me ask you something. Okay. All of you have to answer this. Now say suppose I get this, that this is my best fit line that I have got. Now this is the best fit line that I have got. Correct? Now if I ask you, when the temperature was, say suppose the temperature was 17 degree. Okay, when the temperature was 17 degree, what was the actual sales that happened? When the temperature was 17 degree, what was the actual sales that happened? Actual. How come, Raghu, are you saying someone said so? Yeah. So Raghu, you are right. So Rishabh, you are saying 16 to 7 because I have that number over here, right? Actual number, I already have this number, have that value available to me. Correct. On the 17 degrees, when the temperature was 17 degree, I already know what is the temperature. That is the point that I have put up over here on this line. Correct. That is the point that I put up over here on the line. So what point will be that? That will be this point. Correct. See, these points are random. I mean, very approximated, not very exact. So if I take a look, so somewhere 17 degree will be here and 1514 will be over here. Correct. Am I right in saying this? Yes, class. Others? Okay. Now when I am saying my temperature was 17, actual value was this, what is the predicted value that I am getting? What is the predicted value that I am getting? What is my line predicting at that 17 degrees Celsius? Right, Nandini? So around 1500. I can see from this point, this is what my line is predicting at this point, which is coming around 1500. So I can see that there is some error of marginal error of $14. Whereas when the actual value was 15, but the error was, the actual value was 1514, but my line is telling it is 1500. So there is a slight error that I have. Do you all agree to this? Okay. So now that means at every point. So now there are two things that I would like to check. First thing, are you all understood with that how that best fit line is coming? If any one of you still has a doubt, please feel free to ask. Right? And please do not think like, in just 1 hour, you will be able to understand all the things. You will also by yourself have to put in little bit efforts to revisit the sessions and think on the points and frame your story inside your mind. And if you feel there is still you are having a doubt, ask your questions. Okay? Because I will not be able to know by from here that who has understood and who hasn't. Okay, you will have to ask the question and you will have to come up with the things. I can just I can try my best to deliver the knowledge. So now from here I can see that this was the actual, this was the predicted. So I have got an error over here. So this is the error that I have. So if I ask you for a best model, if in order to check the accuracy, okay, if I have to check the accuracy, how will I get that accuracy? How will I check that accuracy? It will be based on the error. Lower the error, better the accuracy. Correct? As low error as I get, higher accurate my model is. Can I say this? अगर मेरे मॉडल में गलती कम आ रही है तो यानी मेरा मॉडल उतना ज्यादा एक्यूरेट है. Okay, so now this is something that we will be trying to understand over here. Just give me one. So now what you do is, basically, first of all, the first thing that we do is we calculate the average of the sales. Okay, what we will be doing is we will be calculating the average of the sales. What was the overall average in this data, right? We will calculate what is the overall average that we have got. You will calculate the average takings. What is the average sales that you had? Then what we do is we find the error. Okay, after the best fitted line is plotted, there are two things that we do. First of all, we just write down the steps. Please, I will request, try to make some notes as well, right? So that if next time when you open the class, this the videos, you should at least be well aware that what are the things that you did. Okay, it will just help you recollect all the things. Now, after the best fitted line is created, we calculate the average sales. We calculate the error that, okay, this is the actual value. This was the predicted value. So there is some error that I am getting. Some errors are positive, some are negative. And if a point is coming exactly on that line, that will mean that there was no error. Your line also told the same thing. Your actual value was also the same thing. That means there was no error. So that in this point, I don't see any error over here. There is a slight error. There is a big error. There is a big error, right? Once we have calculated these errors, then what we do is we calculate something that is called as residuals and errors. Okay, there are two things that we will calculate. Are you all clear with me? So after the best fitted line, we find the average sale, and then we find the error from that actual value and the predicted value. Then what we do is we basically calculate two things. We calculate sum of square of residuals. This is SSR is called residual, and E is called as the error. Okay. See now what are residuals? Basically, in the case of residuals, what happen is we go by the assumption, right? We will go by the assumption that if I have to predict something, so suppose, if I ask you that if Sachin has been scoring 15 runs in the first match, 17 runs in the next match, 13 runs in the next match, 25 runs in the next match. If I ask you that, that what will be your guess that how much score will he create in the next match? Probably you will go by your first approach as, let me see what is his average score. Somewhere nearby the average is what he will be scoring. Am I right? You will say this thing only. You will say ki on an average he has been scoring around 15, so I guess 15 hi marega, right? You will go by that assumption. Correct? Now the same is the assumption over here. We are not assuming, we are not taking into the consideration that temperature is impacting the sales. Right now, I'm not taking that into consideration. So for that, what we do is we calculate sum of square of residuals. So we assume that average should be what my forecast should be. जो मेरा average sale होगा वही मेरा predicted sale होगा. वही मैं उसको predictions में बताऊंगा कि इतनी sale होनी चाहिए. But there will be a difference between that. अब जो मैंने forecast, the value that I forecasted, correct? The value that I forecasted, that was this, but my average was this. Okay, so there is a difference between these two numbers. There is some error. I will say that I will not call it as error, but that is something impact that I am getting. This is called as residual. Residual effect means because temperature was impacting the sales, because my temperature was impacting the sales, that is why my predictions has come different from the average. So that is we call it as a residual effect. Residual effect, that temperature is impacting the sale. If my temperature will change, my sale will change. It will not be equal to average. So that is why we calculate what is the difference that we are getting from the average. Okay, we find that difference. Getting my point? Yes, class? Class, please, I will just need some little, interactiveness. You can also speak if you have any doubts. I just want to ensure that, we all go with the same page. Now, can you tell me why I have taken the square? So, Harmeet, why have I taken the square over here? Y cap minus Y bar. So, what is Y cap? Y hat. We not call it, someone call it as cap, some call it as hat. So y hat is what? And what is y cap?
Actually, we take cap thing because हम लोग नहीं चाहते कि पूरा का पूरा zero आए. Actually, all the values
Perfect.
जो हमारी line जो यहाँ आ रहे हैं zero ना आए
Right.
बिल्कुल भी. तो इसलिए हम लोग ने squares लिए हुए हैं.
Correct. So if you see over here, I can see there is a negative impact, and over here it's a positive impact.
Yes.
So if I will not take the square,
Positive impact.
it can come as zero. It can come as zero. Perfect, right? So that is why we are taking the square. So now one thing is clear to you. Now, what is y hat and what is y this cap over here? Just understand y, wherever we are talking of this y bar, this is the mean. Y hat means the predicted value, and y is actual value. These are the three things that we are talking of. This y bar is the mean value. This is predicted value. This is actual value. The y is actual value. That is this. Okay. Now, so we have calculated the sum of square of residuals. That this is how, because of that impact of temperature, my value will not be equal to mean. So it will be either higher or lower. So that is why there will be some difference that I will get. So I'm calculating that effect of residuals. Then what I'm doing is I'm calculating the error. So error, we were just talking in the previous slide also, because my actual value is this, my predicted value is, there is the error that I am getting, correct? There is an error that I am getting. So again, I am calculating the error as well, sum of square of errors. So what is the total residuals and what is the total error? Now these two things I have calculated. Any questions up till here, anyone?
Amit, this is Nandini here.
Yep.
Yeah, so we are clear with the topic. Okay, what the doubt I have is in real time example when we are in workplace, in which places that we will be implementing. So we studied about linear model and this means what standard error, everything. Okay, so but in real time, real world, like when it comes to work, where we'll be implementing. So we when we
So Nandini, I just got your question. Just stay with me for 5 more minutes. You will get the answer by yourself. Okay. So you will answer this thing by yourself. Now, what we have done over here is I have calculated the sum of square of residuals and I have calculated the sum of squares. Now what I'm doing is I am calculating sum of square total, that is SSR plus SST. I am just adding these two numbers now. Okay, class? So what we are doing is we are adding these two numbers, SSR plus SST. So that way I will get the SST. This is the formula of SST that I will get. I hope this is clear to all of you. Simple addition of these two numbers. I get this formula over here.
Amit, y bar is a predicted value, right?
This y bar is the mean value. Y hat is the predicted value. So you see y hat is coming over here also. Y hat is coming over here also. So y hat is the
here in SSE. Here
in SSE. This E. Yes. That is the predicted value. This y hat. So we call it y hat.
And y is average. Y is the average value.
Sorry.
This y hat is a predicted value and y is the average value.
No. Y is actual. Okay, actual value.
Okay.
This y that you have at the top like this, a line, this is mean value, and y with a symbol like this hat on this is the predicted value. Okay. So if I just show you something again, if you will come over here, you see this y, this is predicted value y hat. This is y bar. Okay. And this was the actual y's that we have over here on this line.
Actual value.
Right?
Thank you.
So then what we are doing is we are calculating the sum of square of total, SST, which is nothing, SSR plus SSE. Okay, so Uma, SST is sum of square of total. Okay, let me just write them down for you. So when we talk of SSR, this is called as sum of squares of residual. Okay. SSE is called as sum of squares of error, and SST is sum of squares total. Correct? This is something that I will be now, this SSR, SSE and SSE. This is very important from the interview perspective as well. Okay, this is 110% questions that will be asked to you whenever you will go for any of the predictive modeling interviews. Because I myself also ask this stuff from a lot of people when I hire them, right? So, and this is a general notion that I've seen with the other the firms as well. So now if I'll show you something, now what I've done is I'm calculating SST, right? This is some simple sum, SSR plus SSE, that's it. Okay. Then what we do is, why I have calculated this SSR, SSE and SST, why I have calculated all these things. I have calculated all these things to calculate R square. Okay, what is R square? So just let me show you. R square is, so this is called as coefficient of determination. This is the meaning, the full form of this. R square is called as coefficient of determination. Okay. So now if I come back to this, I am saying R square equals to SSR by SST. Now please all of you take a pen and a paper at your end. Okay. Please take a pen and paper at your end. Bhuvneshwar, you have a question. The mean that we are talking about is the mean, Bhuvneshwar, the mean that we are talking of is that is the mean of the actual values. The mean is of the actual values that we have. Have you all written the formula of R square equal to SSR by SST?
Amit, I have a question. So I understood why we calculate SSR, right? So in order to understand how far are we from the actual value, why do we need an SSC or an SST? I mean, other than the fact that we need to calculate R square.
So there is this something that is missing in your understanding. So let me re-explain you that thing. See, what we are assuming is I give you. So let me just give you this one more example over here. Okay, so that you can just understand it in a better way. I say you that I'm giving you the data of, say, suppose Big Bazaar, or maybe let's take a smaller example. Rather, let me give you an example of the. So just assume that you don't know anything about predictive modeling. You do not know anything. You are like completely blank. You are a new beginner. I tell you that, okay, Bhuvneshwari, so on day one, I had a sale of 700. On day 2, I had a sale of 600. On day 3, I had a sale of, again, say suppose 650. What day 4, I had a sale of 750. Okay. And day 5, I had a sale of, say suppose 720. Now I ask you, Bhuvneshwari, okay, can you please tell me what is the sale that I can expect on day 6? What is the sale I can expect on day 6?
I think closer to the average.
Right. So you will tell me, okay, somewhere around you will say, I see that 600. So that will revolving around that. So you will say, okay, this sale has been around 650. You will say, come up with this. You just gave me an average, correct?
Right.
Right. So this is the same thing. The first thing that we have done, that we just calculated the average. So when I'm calculating the average, I'm not taking into consideration the temperature anymore. I'm just taking the average of bars takings. What was the sale that I had? But now I give you that information. Okay, Bhuvneshwari, you know, on this particular day, the temperature was 25 degree. On this day, temperature was 26 degree. And you had a temperature of 27 degree, 28 degree. So I give you some information of the temperatures also. Now what you will do is, now you have a little bit understanding of predictive modeling now. So now you will not give me the average. You will see, you know, that temperature is impacting the sales. Okay, temperature is impacting the sales. That if the temperature is increasing, maybe the sales are increasing. When the temperature is increasing, the sales are decreasing. So that is something that is called that. So that is something that is called as residual. That another variable is impacting somewhere the values that you are getting. जो आपकी सेल हो रही है वो आपकी चेंज हो रही है because of the temperature, correct?
Yeah.
So that is why what we do is we calculate
the coefficient part of it, right?
No, not right, not that. The sum of square of residuals. This is, we are calculating the residual effect.
Right.
क्या वेरिएशन आ रहा है आपका कि वो एवरेज से कितना चेंज हो रहा है, जो आप प्रिडिक्ट कर रहे हो वो एवरेज से कितना डेविएशन आ रहा है उसमें, ठीक है ना? सो दैट इज द दैट यू कैप्चर ओवर हियर, सम ऑफ स्क्वायर ऑफ रेसिड्यू. उसको बोलते हैं सम ऑफ स्क्वायर ऑफ रेसिड्यू, एसएसआर.
Okay.
Right? And then what we do, so now then what we do is we calculate the next part is sum of square of error. अब एरर क्या है? आपकी एक्चुअल सेल इतनी थी और आपने प्रिडिक्ट किया इतना, तो ये आपका एरर आ गया. So that is what we are capturing over here. We are adding up all the errors in this. So SSR is the variation from the mean, and SSE is the error between the actual and the predicted value. Now these two terms are clear, SSR and SSE?
Yes.
Okay. Now in the SST, what I'm doing is I'm simply adding these two numbers together, nothing different. SST is equals to SSR plus SSE. That's it. So which is called as sum of square of total. तो हमने दोनों का टोटल निकाल लिया कि एरर प्लस रेजिडुअल इफेक्ट कितना आ रहा है.
This becomes more very practical in the scenario of the supply chain, you know, where if your prediction between the demand and supply is kind of either over, you know, like it's kind of at a higher level, then probably you might not be able to meet up to the expectation.
No, it is not related to that. It is something that will be related to everywhere. All the linear models that we create, it will be related everywhere. So see, just give me one more minute. Let me just close this part R square. Okay, you will be able to get everything. Have you all written the formula of R square equal to SSR by SST on your notepads? Okay, so the formula that you all would have written is, that would be this. Then R square equals to SSR by SST. Now just expand this formula. SSR, because I know SST is equal to SSR plus SSE, right? So instead of SST, write this in your formula. Written? Have you all written that formula? R square equal to SSR divided by SSR plus SSE. Have you all written this? Okay. Now, say suppose my SSE increase, if I say my SSE increases, okay, what will be the impact on the R square? Will it increase or will it decrease?
Increase.
Harmeet, please take a look at the formula one more time. I am saying if my SSE increase, will my R square increase or will it decrease? Right? It will decrease. Because error is in the denominator. Right? Your formula is this. You are saying SSR divided by SSE plus SSR, right? If you increase the denominator, overall value decreases, right? If I have 2 by 5 and 2 by 10, अगर मैं नीचे डिनोमिनेटर को बढ़ाऊंगा तो मेरा पूरा वैल्यू कम हो जाएगा ना, राइट? अगर मैं 2 के नीचे 5 है और एक में 2 के नीचे 10 है तो मेरी ये वैल्यू छोटी होगी या ये वैल्यू छोटी होगी? Which value will be small? This one? Sorry, this one? This one will be small. If I'll increase the denominator, my value will, if I increase the denominator, my value will decrease, overall value will decrease.
That's right.
Okay. So let me repeat my statement over here. So I am saying if I increase my error, what will be the impact on the R square? मेरा R square कम हो जाएगा, right? My R square will decrease. So what was SSE? That was the error. If my model has more error, my R square will decrease. Am I correct in saying this? Okay. Now if I say my error is 0, I am saying my error is 0. What will be the value of R square? I am saying my error is 0. What is my R square? 1. 100. How come 100, Ashutosh? Right? So I am saying this is 0. So SSR by SSR, दोनों आपस में cancel हो जाएंगे, so it's 1. Right? Now if I say, okay, so if my error is 0, so you are saying R square is 1. If my error is 0, can I say that my model is perfect? If my error is 0, can I say my model is perfect? So if I say, if my R square is 1, can I say my model is perfect? If my R square is 1, can I say my model is perfect? So Rishabh, not mostly, it's every time. So if your error is 0, तो अगर आपके मॉडल में एरर ही नहीं आया तो R square की वैल्यू 1 हो गई, और R square अगर 1 हो गया तो यानी एरर नहीं आया. If I don't have error, I have R square as 1. So both are, in both the cases, I mean that my model is perfect. I do not have any error in that. So whatever my actual value is, the same is the thing that I'm predicting. Got it? So now this whole story that I have explained you, okay, the whole story that I have explained you, now that will take me back to my model. I told you one thing, that we only take a look at the R square. This R square, all this mathematics that I have explained you was just to explain you this portion, R square value, that how do you get this R square. Now the R square is coming 0.9504. Okay, R square is value coming as 0.9504. What does this mean? Right, so as good as 1, that means almost perfect, right, Bhuvneshwari? So as good as no error only, right? So Nandini, now do you get your answer? Why are we finding all these things? The real-time scenario?
No, Amit, this is not my question.
Yes, please. Then,
So
yeah.
my question is, we are finding this linear model and we are finding all these values. Okay. So means to find this, what will be the basic requirement? So the requirement will be something, right? So for example, when we take visualization, the requirement is like with the help of this data set, you will have to create a visualization or something. So that will be the requirement. Okay. So here in this particular place, when what requirement we get, we will have to go with this. So that's what my question. So I'm relating this with working environment.
No, visualization is something that we do under EDA process. Remember when we were doing the univariate analysis, bivariate analysis, when we were trying to understand that how that variable is behaving or what kind of values that variable has. So visualization is something that we do in that part. Now these things that I'm explaining you over here they are related to the model, that how that model is created and how the values are predicted in the background.
Yeah, that I understood, Amit, but why we are predicting this?
Predicting as in, I think
I
I'm
mean,
not
why
clear
we
on the
are
question.
calculating all these, like, linear model and everything? Why we are calculating this in the work environment? So when it comes to concept, it is fine. We are finding all these things, okay. But when we work, means when we work at office, the requirement will be coming, right? So in that place, in which.
So the requirement over here, right? So I want to predict, say, suppose I want to say that today the temperature is 15 degree. I would like to predict what will be my sales.
Okay.
Right?
But
so
this we will not get in working environment, right? To understand the concept, this example is fine. So my question is, in the working environment, we will be dealing with so much data, lakhs of data also we might deal with, okay? So in that time, why we are calculating all this? That's what my question.
No, see, first thing is concept. Now in the real time also you will have the same thing. It is just that the data size will increase, but the concept will not change. Now if I give you something like this, okay, so let me show you something over here. Okay, so now this is the data that I have. Now I am showing you, so you wanted to see a huge amount of data, so I'm just showing you this huge amount of data over here. And this is a project that we will be doing in the class as well. So this is a data related to the houses. Okay. So what you want to do is, over here you want to predict the house price. Okay. So now what are the features a house has? Say suppose if a house is of big size, its amount will be high. If it has more number of rooms, its price will be high. If it has a garage, if it has a bathroom, 3 bathrooms, 4 bathrooms, all these things, will they impact the price of the house? Right?
Yes.
Right? So over here, what I'm trying to do over here is I'm trying to predict the sale price. What should be the price of the house based upon the different independent variables. So this is the kind of a situation that you get in your real time. So which is as good as the same situation that I have explained you over here, that a bar comes to you and he says on a particular temperature, what will be the sale I have, so that I can be well prepared for that. If a sale owner knows that if today is 16-degree temperature, I will have a sale of 20,000, he can make the arrangements according to that. He will not be in a problem that if he already knows that the sale will be high, he will keep the stock according to that. The day he will know that the demand will be low, he will keep the stock according to that. Correct?
Okay.
Are you still having any confusion? Please, you can let me know.
I'm partially getting it, but partially not getting it.
So what part are you not getting it?
See, how come sale will vary based on the temperature?
So do you eat ice cream?
Yes.
Do you like ice creams? Do you eat them in the winters? Do you eat them in the winters?
Not mostly.
In the summers?
Yeah, more.
So is the temperature impacting the sale of the ice cream? Yes or no?
Yes, yes.
Then you have already given your answer by yourself. Temperature is impacting the ice cream sale. Nandini is not eating the ice cream in the winter, but she is eating in the summer. Why so? Because temperature is high.
Okay, so that is fine. Okay. So whatever we are predicting, that linear model, where we are using in the sales price, we are using it.
All the scenarios wherever you have to predict the number, you will be using a linear model over there.
Okay. Can you relate one example with that for me?
On linear regression, you want one more example?
No. This file you explained, right? So this, can you relate with that? Like we have all this data. So the linear model, whatever we found, how come it is relating with the, linear model we are finding is predicting the sales price. So technically, I would need you to relate.
No, technically, as in what sense? I mean,
see, Amit, you told like the sales price, the linear model we are using because to predict the sales price, because when the temperature changes, the demand will change. Okay.
correct.
So that's what you explained me. So here we are, here you meant like the sales price will change based on the temperature. Okay.
Correct.
So
Yes.
how the sales price, how we will be calculating that sales price based on the temperature?
So that is the equation that we will get. So that is the same thing that we calculate over here, the linear model that we have created, sale, salary, and so are you working right now? So Nandini,
Yes.
are you working or a fresher?
Yes. Working
You're
professional.
working? So just tell me one thing. Don't tell me, I mean, I'm not asking your salary over here. So when you started your job, you were a fresher. Say suppose you were
Yes.
getting a salary of 5 lakhs.
Mm-hmm.
Okay. After how many jobs have you switched?
One only.
Okay, only one only. So say suppose after 1 year you got some appraisal, your salary increased to 5.5.
Mm-hmm.
Every year salary is increasing. After when you had 2 years of experience, your salary increased and it became 8 lakhs. Suppose 7 lakhs.
Yes.
After 3 years, it became 8 lakhs. Okay.
Yeah.
So can I say that as your experience is increasing, your salary is increasing?
Correct. Yeah.
Correct. I'm saying okay.
Yeah.
So now this was the same data that I had, experience and salary.
Mm-hmm. Yeah.
We can see over here, experience is increasing, salary is increasing.
Yes.
Okay. Now, if you have to make a chart on this, the same chart, the chart that I had shown you on the bar taking and the temperature, here you will have experience.
Mm-hmm. Yeah.
And here you will have salary.
Yes.
Will you be able to make a predicted line on that?
Yes.
Okay. You have made a predicted line. You will come up with this equation after that, y equals to mx plus c.
Mm-hmm.
This is the same equation that I have in the model also. So if I show you the model, in this model, it is telling me that this is the value of constant and this is the value of m. So if Nandini has 1 year of experience, her salary will be, let me show you. If Nandini has 1 year of experience, her salary would be 3,42,000. This is 34,231. So
Yes.
when her experience is 2 years, Nandini's salary becomes 43,000. When she gets the overall experience of 3 years, Nandini's salary becomes 53,000. So do you see that as the experience is increasing, your salary is increasing? This is same thing the model is telling me.
Yes.
Can I predict the salary? Can I predict the salary based on this?
Yeah.
Correct. Now I also have to check that salary that I am getting. How accurate is this? it might happen that Nandini was getting in-hand salary of 50,000, but my model is 44,000, right? So Nandini will be like, hey Amit, how can you reduce my salary? Brother, I'm getting this salary, right? So in order to check that accuracy, what I am doing is I am finding the value of R square.
Okay.
So if R square is close to 1, that would mean that the salary that I predicted is almost what Nandini was getting. Okay, if your salary was 50,000, if I am predicting 48,000, so I am predicting nearly what you are getting. Or if I am predicting 52,000, I am predicting nearly what you are actually getting right now. Correct? See, because I cannot predict exact salary what you will be getting. It will be nearby.
Yeah.
This is the example and all the explanations over here. Now tell me if you have any question.
Yeah, okay. So the client requirement will be to find these like prediction how much we can give salary for this many year of experience. So this will be there when this kind of requirement comes, we will have to go with this linear model and all these things.
Correct. Now similarly,
Okay.
the company will come to you that, okay, now this was the sales that we had in the last 5 years. Can you tell me what will be my sales in the next 3 years?
Okay. Okay. Now got it. Yeah.
Okay. So others, I hope clear to all. Silence. I mean, not clear or clear.
Clear.
Okay, perfect. So now, we have calculated this R square. Okay, I'll just show you something on this. So R square that we have got. So if the R square, if the error is high, you can see from this chart, when the error is high, R square is low. When the error is low, R square is high. So R square value of R square will always be between 0 and 1. It cannot be more than 1 and it cannot be less than 1. Okay. R square value is always between 0 to 1. 0 means that data, your model is full of errors. It is not giving any correct value. And 1 means your model is free of errors. There are no errors in your data. And 0 to 1, you can call it as in the terms of percentage also. 0 means 0% accuracy, 1 means 100% accuracy. And now in the same model, if I am getting a R square of 0.9504, I can say I have a 95% of accuracy in the data. Okay, class? Now, see, now what we have done is, now the last section of this code is left. I mean, of this modeling section is left. On the training model, I have calculated my model. I have seen what my model is telling me, what equations are coming. Now I would like to test them, right? Remember, we created a data of test data set. Now the model that I have created, I would like to take its test. That, okay, model, tell me if this is the experience, what will be the salary? Now I will take its test to understand, is it giving me the nearby values or not? Okay, so how do we do that? It's simple. We just have to create predictions. So I will create a variable by the name predictions. Okay, in this I will say predict. So predict is a variable, function that you get in the R, which helps you predict the values. The values that I was calculating manually, over here I was putting the values manually and then calculating it. Now this predict formula, what this will do is it will automatically put all the experience that we have. It will put 2 years experience. This is the actual salary. It will give me what is the predicted salary. Then I will be able to compare that how much difference I am getting. On 3.2, this is the actual salary that is available in the data, right? Because this is a test, the real data that we had. Against this, I will plot what is the predicted salary that I'm getting. Okay, so let us do it. Predict. In prediction, what it has to use? It has to use my model, the model that I have created. Because this is the model, this way I'm telling that, use the equation that is generated over here. Use this equation and predict the results on what? New data, and new data is test. Okay, so I am saying make my predictions using the equation on this data. And let us see the predictions now. My predictions are ready, and let us see that. So this is what my model is predicting. So this is also a vector, right? Prediction is also a vector. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a vector that I have got. For first row, when the salary was 43,525, my model has predicted the salary of 43,648. Almost as good as that. Okay. When the experience was 3.2, the actual salary was 64,000, but my model has predicted around 55,000. Okay. When the experience was 3.9 years, the salary was 63,000, but my model predicted 61,000. When the salary was 93,000, my model predicted 81,000. Sorry, 93,000, it predicted 81,000. When the salary was 91,000, my model predicted 88,000. Likewise, I can see all the salaries over here. This is the actual and this is the predicted. Okay, so all of you please write the code first of all. So with this, congratulations to all of you for building up your first model over here, right?
Amit, can you please tell us about the predict part once more? This predict.
This function that I have written.
Yeah.
So what I'm doing is I'm saying predict, this is a function. Now in this function, what I'm doing is I'm saying use this equation, this model that I have created, use this model and predict the results on new data. New data is test. So this is like the syntax of this. New data equals to test. So test on the testing data, I want to predict my result.
And all these values, 10 values from the 10 to 10 data.
So sorry.
The 10 test data. But we have a data frame test.
So we had 10 rows in the test. See, if you remember, we had 10 rows in the test. You can see 10 entries.
Yes.
So I have got 10 predicted values. This is what you were asking?
Yes. I mean, like if I have a wedding company, like a wedding planner company. If I want to analyze, if I want to implement this linear modeling in that thing, predictive modeling in that thing, can we do that? Like occasions in wedding, it can be possible.
See, first of all, we have to understand something, the problem statement. Okay, what we do is we start with the problem statement, that what is the problem that we have. Then what we do is we come up and start building up the model. In fact, I will show you something again that can help you out in that scenario. I will just show you a small example of that. Okay, but yes, as you asked the question on the wedding planner, but it will depend. Say suppose you have a banquet hall. Okay, you have a banquet hall. You would like to predict that next year how many bookings you will get. You want to predict something like this. Or you would like to predict like next year how many parties will happen at your banquet. There is a lot of noise. Can you just mute your site? There's some noise that is coming. Yeah. So, first of all, we have to identify the objective that what we are trying to achieve. So, like, the wedding planning business can have a lot of situations where they would like to predict something. They would like to predict what is the revenue I will get next year, what is the number of the clients I will get the next year. So first of all, we have to understand that objective, and then we gather the data based upon that, and then we make our model. So there are steps that are involved. Okay. Right, Bhuvneshwari, so the question that the statement that you have asked, this is the next thing that I was asked to all of you over here. Now, because if you see over here, calculating and comparing the values is a difficult task, right? So can you all bring the predicted values in the test data set itself, that I could compare them next to each other? Try it. I mean, you have the things. You can use cbind. You can use this formula like this also, because you already have a data frame with you, right? That is the test. I can say test dollar. By default, it is giving me these two columns. I will say I want to have a new column by the name predicted, and its value should be equal to predictions, whatever value I have in the predictions, that I should be having over here. That's it. So I'm saying in the test data set, create new column by the name predicted, and in that column, put down the values, whatever we have received in the predictions. That's it. And now if you will check the test data set, you should have that value over there. Okay. So how many find this linear regression to be interesting?
Let's Sahil here.
Yep, Sahil.
In the fourth instance, we have a 12,000 rupee variation. So is that acceptable?
Yep.
Because we don't. Yeah.
See, because this is again, I will be coming to it. When we calculate the error, okay, we never calculate on one-on-one basis, right? If you see, what is my accuracy? 95%. That means out of all the 100 cases, 95% I will be getting the values nearby to my actual values. But there is a 5% of error also.
Agreed.
That in the 5% of the cases, it will give you a wrong value. We have to accept that.
Yeah.
Right. So that is one value if you're getting as a high. So that is a case of error. So when I say my medicine will be 95% effective, I am saying that 5% of the people might get infected with corona even after the vaccination.
Okay. Understood. Okay. Thanks.
But still what we do is, just to make the things double check, we also calculate something called as mean squared error. Okay, we call it as MSC. We will be calculating this as well, mean squared error. Now this is something that should not be that should be somewhere around 10 to 12 or 13%. It should not be more than that. But I will just tell you what this mean squared error is and how do we calculate it. So before that, do you all have this column of predicted in your test data set? Okay. Now, can you all make one more column? So Uma, you are asking something like I'm not able to get. So you are getting 10 values over here. You have the 10 numbers, what I see over here. But your numbers are different, right? So you are getting some 2.124, 4.1223. Your numbers are not into thousands. Can you please check your data once? Okay. So in the meantime, all of you, rest of you, can you please add can you all add one more column in this? That should be the actual minus predicted. That what is the difference that I am getting? I want to have a column over here. That what is the difference that I am getting? Just calculate just calculate a column of that. Add a new column which should give me the difference between actual minus predicted. Uma, will you be able to share your screen? Is it possible for you to share your screen? Because this way I might not be able to understand it, like what is going wrong somewhere. If you could share your screen, I will just help you out quickly. Okay, so I'm just making the presenter over here. Yep, or you can share your screen now. Okay, so if I see over here, I will just have to see the stuff from the little top over here. Can you just go a little up? I just want to see all the steps from the starting. Okay, can you click on the test? Can you click on the test data set? Can you click on test and the top, that data set is already open? Yes. So you have 2 years and this perfect. Okay, so come back to the code. Okay, so model you have created, formula is equals to, no, see the formula has an error in that. The formula that you have written is incorrect. Model, in that model inside the LM, formula is equals to, so I'm just pinging you on the chat, please write that. I'm putting that thing in the chat over here. That line, complete line, I'm putting it up. You can use that line. Yep, so I've shared that line over here on the chat. Just copy this. Okay, run this command, just paste it over here below this, just paste it below this. Yeah, yes, you're run it. Now execute this command once. Execute this. Control enter. So just run this and then run the summary model and then just run all the steps again. You should get the correct answer. Hello? Who are you there?
Hello?
Hello, yeah, Uma.
Hello?
Hello. Yes, I can hear you now.
Yeah, got it.
Oh, okay.
Thank you a lot. Thanks a lot.
No worries.
Yeah.
So now
Bye-bye.
So now what you want to do is I have to add a column of the difference of these two numbers. So how can I add it? I can simply say test dollar. I want to add a new column. I will call it as difference, right? What will be the difference? It will be test dollar salary minus test dollar predicted. I just have to subtract these two numbers. And I can see the difference. Over here, I'm getting a difference of minus 123. Over here, I'm getting 9,000, 1,600, 12,000, 2,800, 6,500. So this is what the error that I'm getting across all the places. The next thing that we do over here is we calculate the square of this. I will calculate the square of the difference again. Okay, square is something that we will be using everywhere. That is why I call it as mean squared error. Okay, remember I have called it as mean squared error. So first of all, what I will now do is I will find the square of the error. So that will be nothing. I will create another variable test dollar square, which is equal to test dollar difference multiplied by the same thing, test dollar difference. That's it. I can use the formula of power also, one and the same thing. Now I get the square of the values. Okay, so now this is, I think I will take a stop for today. Okay, so I've given you a lot of, because again, this MSc, I have given you these hints over here. Now I would like all of you to explore this, that how will you calculate the mean squared error? That's it. Okay, now this is something as a task that I've given to all of you to calculate the mean square error on this. Now this is again simple mathematics. That will be a quick check and some practice stuff for all of you. Okay, class. So in the next session, what we will be doing is we will be starting off with the project of the linear regression, that is the sale house property prediction. So please, all of you, please go through this session of today once more, right? Make your notes, write the codes, understand the mathematics and everything. Still you have any doubts, so definitely, I'm open for all the questions in the next session again. Okay. So one assignment is already there, Yash, but you won't be able to do the assignment yet, because once we do the project, you will be able to pick up the assignments by yourself as well. Okay, but still what I will do is I will put up a small project over here that you can try. You will have to run a similar kind of a code on that, and same way you will get some results. So I will do that with just 2 or 3 variables, and let's see who is able to come up with something on that. Definitely I'll do that. So I will upload a small data set which will not require any cleaning of the data or anything. It will be very clean data with you, just 4 or 5, 3 or 4 variables and 30-50 rows. So I would like to see your understanding what you have built on that. You just have to come tell me which are the important variables and which are not, and what is the R square you have got, and what is your comments based on the R square. I'll do that.
Amit, this is Nandini here.
Yeah, Nandini.
So in the test, we calculated square, right? So is that the sum of square of error?
This thing that we calculated?
Is this SSE? Yeah.
This is not SSE.
Okay.
This is not SSE. SSE is calculated for the R square, which we are not calculating, which the model has calculated by its own. Those things are calculated by the model own. So I'm just calculating.
Then this square is for?
Sorry, yeah, this is SSE only, right? Sorry.
Okay.
I'm really sorry. So this is SSE only. Sum of square of error. This is the actual value minus the predicted value. So this is the same thing. Sum of square of errors.
Okay, thank you.
Sure. And you have to calculate the mean square of errors. Okay, class. So let's connect. So Rishabh, I'll do it not today. If not today, definitely by tomorrow I'll do it. Okay. Yeah, I'll upload this code also. I'll do this as well. So let me just save this. So today is 22nd of November. So I'll just upload this code. Okay, class. So then I'll just stop sharing the screen and let's connect on the next Saturday now. So please try to go to it. So I'm just uploading the code. I'm just uploading it right away. So you will find that code in the folder of R codes, and there goes the file. Yeah. So I've uploaded the code over here. Okay, class. Then see you next week. Thank you. Thank you, everyone.